Right. So, welcome to the week 5, and this week 5 is going to be the two parts, and the first part will explain a little bit about the algorithm and its analysis, and the second one will explain much more details about the algorithm analysis. Okay. And our weekly objectives are these. So we are going to learn how to analyze the efficiency of our program. It's going to call the algorithm analysis. The objectives are memorizing. You have to memorize some definitions and rules of the big O notation. And big O notation is at the heart of the algorithm analysis. Okay, and you have to understand what determines the efficiency of the programs, and you have to understand a really simple algorithms, right? And here you are going to learn your first sorting algorithm, and it's named selection sort. Okay. And then you have to memorize the insertion and deletion of the list, tag, and queues. And pretty sure at this point you are already familiar with these operations. Okay, and eventually I wish you to be able to apply this big O notation analysis to your programs. Okay, so that's our weekly objectives. And because we are going to talk about the efficiency of our simple algorithm and our programs, we are going to discuss a little bit about what really efficiency means, and what's going to be the factors that determine the efficiency of our program or software, right? And these factors, analyzing these factors would be the analyzing. These factors will be the key of this lecture. Okay. So there are many different factors of the programming efficiency, and one of the key factors is the algorithm. Okay, so the algorithm is like this. So insertion operations is the operation, but how to perform the insertion, the mechanism itself, is called the algorithm. Algorithm is a clearly specified a set of instructions to be followed to solve a certain problem or perform a certain instruction. Okay, so to perform a certain insertion operation, this operation should be operation. To perform a certain insertion operation, we have a step-by-step operation instructions, and these are together as a collective. We are going to call it as an algorithm. Okay. Actually, what it does is takes a set of values as an input and produces a set of values as an output. And in the insertion algorithm, even though we are going to call it a simple insertion algorithm, that differs by the data structure. If we use set array-based list, it will take n instructions, n iterations, and that instructions are really different from using the linked list. Okay. Different, right? These are data structures. And what makes things different is that algorithms becomes different. So this data structure and algorithm always appears together, because if we use a certain data structure, that determines what kind of algorithm that we are going to use, right? Because set array-based insertion takes a really different mechanism. So there takes a really different set of instructions to perform that insertion compared to the insertion operations in the linked list case. Okay. Having said that, algorithms can be specified in English as a complete program, or called pseudocode. I will explain more about pseudocode in the later. Pseudocode means this pseudo is in English, it means bogus, right? It's fake. It's not going to learn it, but it delivers the concept. That's the purpose of the pseudocode, and we are going to see an example later, right? So data structures are methods of organizing data, right? And this array list and linked list are the ways of organizing data, and we have seen this, right? In the week 3 and week 4, much of issues were how to store, how to organize data. And actually, our programs are really two things. One thing is the algorithms, and the other thing is the data structures. So this algorithm and these data structures mixed together comes in. What becomes is our program, right? So this algorithm and the data structure, these two things together becomes our program and software. Any big software, any big like big service software, these are just a collection of algorithms and data structures, right? So it's simple as that. And sometimes people separate out the user interface, but even in the user interface case, we have instruction sets about the behavior and the data that are being shown, and in that case still is algorithms and data structure. So it's fundamental. Algorithms and data structure that determines your program, and you want to improve it to improve your program's quality, right?